Good evening. So, this is our new lecture series, the brand new lecture series, where we discuss the algorithm. The name of the lecture series is Algorithm once again. So, it will be a crash course of algorithm. We will review the algorithm concepts once more, and we review it is in a brief manner. See, why I think that the lecture series, or I have to make this kind of lecture series because see, you all know the data types, the variables, the control statements, the repeating statements, and the basic fundamentals of programming. But when you have to solve any kind of problem in coding platform or in interview, so in those interview or coding platform, you have to think the code. You have to think the code in a efficient manner, or in a easier and in a correct manner. But we face some issues while solving the problem, right? So because we learn algorithm and data structure in a theoretical manner, learn programming in other theoretical manner, and we cannot connect like how we use the program, how we use the algorithm or data structure into our language. So I think it is necessary to learn the algorithm, the basic stuffs algorithm in a brief manner, because in mathematics, when we learn mathematics at very child level or beginner level, we first learn the digits 0, 1, 2, 3, these digits, and by learning these digits we able to make large digits. We able to make large digits. So to solve to solve a problem or to solve something, we say it is a big problem. But if you break the problem into smaller part, you will find that this smaller part is like a basic structure. It's like a basic building block. What, like in this block we have used some variable, in this block we use some loop kind of thing, in this block we have some if else kind of thing. So all the basic building block makes the whole problem. So we have to learn the basic building block in a well manner. Okay, so I think that this will be helpful for you. Okay, so in C, let's talk about data types. So in data types, name a few data type. Int, char, float. I will not discuss it elaborately, like what is the range, what is that. I will not discuss that kind of thing. In C, let's talk about data types. I will not discuss it elaborately, but let's see data types. So name a few: int, char, float. This, okay. Let's talk about some conditional statement like if, else. So this make your program a decision maker. Okay, if you have to make a decision in some middle of the code, you will have to use the if and else block. Then comes the there is a variable. So what is variable? Variable is a container where we store the data. Okay, so data type, variable, if else, and then there is for loop, while loop, the control statements, the repeating tool. Okay, so by this we can iterate a variable over and over, and we can generate the output. Okay, so these things are the basic building block of a program. If in a big program we use these things and make and these things. Okay, these are the fundamental thing. So I think that one more concept should be in this basic building block, that is recursion. Okay, so in this recursion is about repeating stuffs. So the main difference between iteration and recursion: in iteration we use bottom up approach. Bottom up approach. Because we let's take a code. Okay, let's find sum of n natural numbers. So what do you use? Let's take a variable sum equal to 0, then take the loop for I equal to 1 to n, okay, and this sum equal to sum plus I, okay, and then at the end you print the sum. So see, this is iteration, okay. In iteration we go 1, then plus 2, then plus 3, then plus 4. So this is a bottom up approach. We take the variable at the bottom level and go to the nth level, okay. So this is a bottom up approach, and we think very fast in the bottom up approach, because you know that we if you are given a code, you solve the code in a iteration manner, okay. Few of you will think about how the code how we can solve the code in a recursive manner, because we learn the recursion concept at very later part, or some of you students or some of you didn't know or don't know recursion better, okay. So we all think the iteration approach, okay. So what is the recursion approach, okay, in this code? So recursion is a top down approach. Recursion is a top down approach. So the code, like sum of n numbers, how we solve the code. So let's take a function sum int sum, okay, and sum of n numbers, okay, and return sum of n minus 1 plus n, okay. So this is a top down approach, because we at first we go to the nth level, like sum of 10 natural numbers, okay. So this how we write sum of n natural numbers plus 10. So we go to the to find the 10 find the sum of 10 natural numbers, and we write 10 and then make the function into a smaller part and write in this manner. So this is a top down approach. So if you see in the code, there is a minor bug, because you see that I haven't used any base case. So if you write the code or if you execute the code, it might fall in the infinite loop, right? So what is the base case? So in this line we write if n equal to 1, return 1. So we assume that we know the sum of first one natural number is 1. Okay, so this is a base case, and to write the base case we can stop the code, we can terminate the code. So it is very necessary to think a top down approach. And there is another level of thinking, the recursion, okay. In iteration that is process state thinking, because we think about the process, like when I equal to 1, I will store the variable 1. When I equal to 2, this is 3. So I think we will think every process. But in recursion there is a concept end state thinking, okay. So what is end state thinking? I will think at the end state, okay. So what I have to solve? I have to solve first n natural numbers. So what is the first n natural? Let's suppose 10. So I have to think for 10 natural numbers. Then I have to think for 9 natural numbers. Then I have to think for 8 natural numbers. Okay, so it is a end state thinking. So there is a you see minor difference between recursion and iteration. So many of you might ask or might have a question that what is efficient, recursion or iteration? See, iteration is more powerful than recursion, right? Because in iteration you see, because something, a concept called implicit stack. So please don't go into the jargons. I will discuss these things, what is implicit stack or what, in the latter part of the lecture. So recursion uses implicit stack kind of part. So by using this, it will create very much memory, and in stack there is more function calling, and it use very much memory compared to iteration approach. So iteration is more powerful than recursion, but there is a catch. What is the catch? Now there is a concept called tail optimization. I again tell that don't go to the big term like that. I will discuss and I will make you feel better, make you feel very comfortable about these terms. But at first, let me say this, or let me describe this. This is tail optimization. So recursion uses some tail optimization kind of approach. By using this, we can make recursion better than iteration. Okay, so I will discuss tail optimization later. So tail optimization later. The recursion, what it gives, that it, by using recursion you have to write less line of code, right? You see that by to solve some first in natural numbers, we have to use just one line of code and if block only. So by using recursion you can have less line of code. Okay, so if you understand the sum of n natural numbers example, that's okay, but let me discuss another example. Okay, so like you are in a movie hall, you are in a theater. Okay, so in theater movie started right 5 or 6 minutes ago. So you enter, you got the ticket and you enter the hall. Okay, so your ticket shows that you have seat in the 5th row. So in the dark hall you can't see where is the 5th row or what. So you ask every man or every people that sir, what is your row? So like you enter, this is the door and you enter the hall. Okay, and there is cinema hall, and there is cinema hall seats. Okay, this is seats. This is seats. So you enter and ask this person, sir, what is the row? And he or she also know that is dark screen and the dark environment. So he or she didn't know that what is the row he or she has. Okay, so he or she sits a long back ago, so he or she forget about the seat row or something. Okay, so he or she said I didn't know. So he or she asked him. Okay, and then he asked him. Okay, so he asked him and he asked him. So at the end he see that is a floor, that is a ground floor. Okay, it is a ground floor. So he said that it is the first row. It is the first row. He acknowledges that it is the first row. So he passes to him, and then the pass go on. Okay, so at the end these people acknowledges that it is the first row, and he tells that sir, it is the first row. It is the first row. It is the first row. So this is a recursion like thing. See, we first we go to the problem and we go deeper and deeper and deeper, and we find the solution. And after finding the last solution, we will move to the next solution. We will move to the next solution. We will move to the next solution, and at last we found the ultimate solution. Okay, so this is a thinking the recursion, how to think recursively in an intuitive manner. This is a recursion kind of thing. This is like a stack kind of thing, recursion stack kind of thing. I will discuss about recursion stack further, but this is a approach you can think intuitively, like how you can think something recursively. Okay, so this is a thing. Sum of first 10 natural numbers. As you see, I have discussed it earlier, but let's see how the recursion works in algorithm manner. Okay, so I have written the code before. Sum of n, if it is the base case, if n equal to 1, return 1, return sum of n minus 1 plus n. So you have to simpler the function more and more to get the code. Okay, so how I said that how recursion is less efficient than iteration, I will tell. Okay, so I will tell now. Okay, so recursion itself uses a stack function. It's called implicit stack. Okay, so how? So when you call sum of 10, it will call sum of 9 plus 10. Then it will call sum of 8 plus 9. Then the end sum of 3 plus 2, and then sum of 2 plus 1, and then sum of 1. So this is a base case, I have told you. So this is a base case and this returns 1. Okay, and then this returns 1 plus 2, 3. So at first it will store sum of 10, sum of 9, and end sum of 1. So see, the recursion itself store the functions and pop the function as output whenever it reaches to the base case. So so it follows the LIFO data structure. Okay, so anything that comes last function has to be has the output at first. Okay, so this is the top down approach I have told you. So now I can assume that you will understand how the top down approach works. So this is why iteration is better than recursion. Okay, so how you can optimize recursion? I have told you that there is a concept called tail code optimization. So it is very advanced data structure topic. So I will give the link in the description below. You will see, because it is out of the bound here, because many interviewer don't ask in this domain questions. So okay, I will discuss later and I will give the theory in the description, so please watch. So then let's discuss some more problem. Okay, so let's discuss Fibonacci. So let's discuss factorial. Okay, factorial of n numbers. Okay, so I will give you a trick that how you can solve recursion. Okay, so there are 3 steps. So the first step, break the problem into smaller and subproblems. Okay, so first get the problem like factorial of n, and then you have to break the problem into some similar and smaller subproblems. The trick is called leap of faith. Leap of faith. So you have to believe in heart that whatever happens, I will still break the problem into some similar subproblems, and at last I will get the result. So you have to faith on your custom function. Okay, so first step is break the problem into smaller and similar subproblems. Then express the subproblems in terms of current problem. How? I discussed sum of 10 equal to sum of 9 plus 10. So you express the subproblem in terms of the current problem. Okay, so this is step 2, and step 3, find the base case. Okay, so this is the 3 step. You have to find the base case, because otherwise the code might fall in the infinite loop. Okay, so let's discuss factorial of n. How you solve. So if n equal to 0 or n equal to 1, then return 1. This is the base case. Okay, return. So I have told you, break the problem into similar subproblems. So what is the similar subproblems for factorial of n? This is factorial of n minus 1. And second, what I have told, that you have to express the subproblem into the current problem. What is the current problem? N. And how you express the subproblem? N into factorial of n minus 1. So this is, you write, because have a factorial 5, then 4, then 3, then 2, then 1, so 120. So this is the program. And let's come to the last problem. It is the famous problem of recursion, and this is Fibonacci numbers. So I assume you know what is Fibonacci number, like 0, 1, these two numbers sum 1, 1, 1, 2, 2, 1, 3, 2, 3, 5. So this is Fibonacci number. So it is also the base of the dynamic programming. It opens the door of dynamic programming. So every student has a roadmap. I learned dynamic programming by learning this. The disadvantage of this, I learned dynamic programming. So I will discuss about this for later. So how you can write Fibonacci numbers program. So let's take a function int Fibo of n. Okay, so if n equal to 0, return 0. Then if n equal to 1, return 1. These two are base case. And then again return. So you have to divide, you have to determine the sub problem. Okay, so how? So you see 0, 1, 1, 2. So how you get to? By adding the previous two elements 1 and 1. So how you determine this? By code. So return Fibo of n minus 1 plus Fibo of n minus 2, right? Because that's you can get the result 0, 1, 1, 2, then 1, 2, 3. So you need the previous and previous to the previous. Okay, so this is so I explain what is dynamic programming little that what is the disadvantage of this. See, Fibonacci of 8. So sometimes recursion can very tedious, right? Because you might see some similar sub problem, because for Fibo 8 you have to Fibo of 7 and Fibo of 6. For Fibo 7 you have to Fibo of 6 and Fibo of 5, and here 5 and 4. So see, you determine Fibo of 6 one time, then you determine Fibo of 6 second time. So similar sub problems merge one onto the another, so it will affect time complexity at a very great extent. So what is the time complexity of this code? You see, this is a binary tree and divides like 2 to the power, so 2 to the power format. So the time complexity will be exponential, right? This is very bad. So the worst case time complexity will be order of 2 to the power n. So what we will do in dynamic programming, we will find that what is the sub problem, that is give the same output, and we store the same output result in a different variable and use this thing later. So we have not to determine same custom function once and again. So dynamic programming helps in that way. So you have to use your recursion program very carefully. Okay, you might fall into this kind of great worst time complexity. Okay, so my suggestion is that you take 10 or 12 or 20 codes and you try to solve this in iteration manner and the recursion manner, and you whenever you solve like 10 or 20 problems, you find the difference, that how recursion works differently, and you will find recursion very comfortable concept. Okay, so thanks for watching and subscribe us. Okay.